In this video, we will look at how can we use Excel to calculate the probability for binomial distribution. And the example I'm going to use is about a motor company. The motor company has purchased steel parts from the supplier for several years and has found that 10% of the parts must be returned because they are defective. An order of 25 parts is received. So the description of the business cases help us to identify the value for parameters. As we know, for the binomial distribution, we only have two parameters, n, which is individual trials, p is the probability for success. Based on this case description, we know the success is defined as the parts are defective. So if we found the parts are defective, and we call the event as success. So after we define the value for n and p, and we can start to look at the value for x. So the first question it asks for what is the probability that one part is defective, which is to say the x equal to 1. So now we can open our Excel file. And I've already write down the value for n and p given our business cases. And then now the first question we are looking for is x equal to 1. So the probability for x equal to 1 given the variable following the binomial distribution is equal to, remember the function we will use, equal sign BINOM. So the nice thing for the Excel is it will give you the a hint about what kind of function you want to use. So you have binomial BINOM dist. As I mentioned in the lab, the dist means the distribution and a parentheses. So the first entry it said it's the numbers, so which is you will use 25 and the common. The numbers, which means the value for x, and as we know we are looking for x equal to 1, and the trials is the individual trials, we have 25, and the probability means the probability for success is equal to 0.1. And as I mentioned, if we only calculate the value for one data point and it's not a cumulative distribution, then we type in force and close the parentheses and push enter on your keyboard. And then you will get a 0.1999416. Now let's look at the second question. So the second question is asking for what is the probability that two parts are defective. So which means the probability equal to two parts, and we got the second question actually asking for what is the probability for x equal to 2. So you type in probability x equal to 2. So again we will use the same, exactly the same function, equal by binom dot dist and the parentheses 2, which is a value for x, and a common, the individual trial is 25, common 0.1, which is the probability for success, common. Again, we are asking for the probability for one data point. It's not the cumulative, so we type in force, FALSE. Close the parentheses and push the enter on the keyboard. So 0.265888 is the probability for us to find two parts are defective. So now let's look at the last question. What is the probability that no more than 3 of these parts are defective? So what is no more than 3 means? So if we translate this question to math language, and we will get what is the probability for x smaller and equal to 3. So the third question actually is asking for x smaller and equal to 3, no more than 3. So as I mentioned, we have two options to get this probability, x smaller and equal to 3. So as we found, x smaller than or equal to 3, actually it is equivalent to C. We're trying to get the probability x equal to 0 plus probability x equal to 1 plus probability x x equal to 2 plus probability x equal to 3. So if we add these four probabilities together, we will get probability x smaller than or equal to 3. And also we can consider this question as we're asking for the cumulative probability distribution from smallest value of x to the maximum value of x equal to 3. So first let's use the first approach to get the probability. So which means we will calculate x equal to 0 to x equal to 3. So equal to binomial dist 0, 25.1 and fourth, and equal binomial distribution 1 and 25 and 0.1 and fourth, and binomial the dist and 2, 25.1 fourth, and equal binomial the dist parentheses, and the last one 3, 25.1 fourth. Then we add all these four probabilities together and push enter. So the probability of x smaller than or equal to 3 is equal to 0.763591. So this is the first approach. As I said, if we look at probability x smaller than or equal to 3, we can link it to the cumulative distribution. So the cumulative distribution we can use is still equal, and binom the dist and parentheses, and we need to look at the upper boundary for this for the value of x. So the upper boundary is equal to 3. So x can reach maximum can reach to 3, and the common, and we have 25 trials and 0.1. And as I said, this is a cumulative distribution. Then we choose true and close the parentheses. And we got exactly the same answer, 0.7635, as what we got through the first approach. Here, you need to pay attention on what condition you can use the cumulative distribution to calculate the probability for binomial distribution. You need to remember that the case we can use cumulative distribution is when we are fixing the probability that they can have the upper boundaries. So in this case, we are looking for x smaller than or equal to 3. So the upper boundary for x is 3. However, if we are asking for x large than 3, we cannot use this approach. If we are looking for probability x large, if we are looking for x, probability x large and equal to 3, and we cannot use this approach. We need to use 1 minus the probability x smaller than 3. So to get the probability for x large and equal to 3. So this, as we said, is equal to 1 minus the probability x smaller equal to 2, because for this case 1 minus probably x smaller than 3, the x cannot be 3 because it doesn't include the equal sign. So this calculation equivalent to say you are doing calculation use 1 minus probability x smaller and equal to 2. So this is the how can we use the Excel to calculate the probability for binomial